Welcome to lesson number 5, multiplication of rational expressions. Now, believe it or not, you might find that multiplying rational expressions is easier than adding or subtracting them. So, when we're multiplying rational numbers, we need to consider the factors of the numerator and the denominator. So what numbers go into both the top and the bottom. If there are factors that are common, we can reduce by dividing out the common factors. And the next step is to multiply all the numerators together and the denominators together, just like you would in a regular fraction interchange. So let's look at these first two examples. If you have 7/10 times 1/5, remember that if you're dealing with fractions, you can just multiply across the numerators and the denominators. That would give you 7/50. On this next question, just like we're told here, reduce by dividing out the common factors. We have a common factor of 3 between 9 and 6. And so we could say that that's 3 and that's 2. But we also have a common factor of 5 between 5 and 10, which goes into 5 once and goes into 10 twice. So we've reduced this. Now we can multiply to give us 3/4. Now when we're multiplying the rational expressions, it's going to be the exact same. The only difference really is that we're dealing with variables and we need to state the restrictions afterwards. So the first thing I'm going to do is consider the factors of both the numerator and the denominator. So between 12xy over 4z times 3xz squared over y, there are some common factors involved here. First of all, I have my y's, which are common, which I can cancel out. And I also have a z on the bottom and a z on the top that can be canceled out, which leaves me with one z on top. And now there's nothing else that will cancel out other than the common factor between 4 and 12. So 4 goes in 12, goes in 4 once and goes in 12 3 times. And we're going to be left with nothing on the bottom, but on the top we'll be left with 9x squared z. And so you can see where those x squareds come from. And I'm multiplying this 3, and I'm left with that z as well. Now we need to state the restrictions on the variable. We're going to use our original expression, which was over both of these numbers over 4z and y. So the restrictions on my variable is going to be y cannot equal 0 and z. That does not look like a z, but z cannot equal 0 as well. Okay, so let's look at this next one. If I'm given 5a squared b squared c fourth divided by 14b squared cd times 35b over 40a cubed c, I'm going to begin by canceling out my, well, first let's start with our coefficients. So if I have numbers that can go into both of these, I know that I have 5 that can go into the top and bottom, right? So I have 5 that goes into, or 7 that can goes into these two. Let's do that first so I can get rid of this 14. So 7 goes in that twice and goes into 35 5 times. Now I can look at this 5 and this 40. 5 goes in this once and goes into this 8 times. Not 80 times, 8 times. And so now I'm left with my coefficients, which are going to be 5 times 1 is 5, and 2 times 8, which is 16. So 5/16. But I also have all my variables I need to take care of. So let's begin with my my a's. Okay, so I have a squared on the top and a cubed on the bottom, which means that there's 3 a's on the bottom and 2 on top. So I can cancel out both of these a's and one of these ones, which would just leave me with a. So 16a. I'll highlight the ones that I've taken care of, so we don't have to worry about them anymore. Now let's look at our b's. I have b squared on the top and bottom, so those will cancel out. And then I'm just left with 1b. And that is right here. Now if I look at my c's, I have 2 c's here, which means that I can multiply those together to give me c squared, but I have c4 on the top. So if I cancel these out, that would cancel out 2 in the top, leaving only 2 left, which would give me c squared. And now I can't cancel out anything else, but I do have this d left, so that would be my final answer. And my restrictions on my variable are going to be a can't equal 0, coming from here. B can't equal 0. C can't equal 0. And D can't equal 0. Excuse me. Okay, now let's work with single variable rational expressions. Okay, so something like this, although it looks complicated, is actually easier than you're going to expect it to be. For a question like this, the first thing we're going to do is consider the factors between the numerator and the denominator in both cases. Remember, if there are common factors, reduce by dividing out the common factors. So let's divide out the 1 or x plus 1. That's a common factor here and down here, so we can divide that out and just say that it's left with 1. We can do the same thing with the x plus 3's, divide them out, and then we're just left with these parts of our expression, 2 over x and x minus 2. And so the next thing we do is just multiply those together, and we're left with 2 x times x minus 2. And then my restrictions on x are going to be -3, -1, 0, and 2. With a question like the one I have here, what we need to do is consider the factors again. Okay, so what factors do I have for the top and the bottom? Well, if I look at the top here, and if I look at the bottom of my first term, I can factor both of those. So on the top I can factor 4 out, leaving me with 4x plus 4. And on the bottom I can factor out a 7, leaving me with 7, 2x minus 1. And then I'll have this side, which will be 2x minus 1, and x plus 4 times x plus 4. So once I've considered all my factors, I can divide them out or cancel them out, and I can cancel out one of these this x plus 4 on the top and this x plus 4 on the bottom, and both of these 2x minus 1s. I still am left with one of these x plus 4s because it was squared. And so if I multiply the 7 by this x plus 4, and then this 4 by nothing, or by 1 essentially, then I'm going to be left with 4 over 7x plus 4. And then my restrictions, x can't equal 4, and that's a -4. And if I look at my restriction with the 2x minus 1, x also can't equal 1/2. Okay, so we're going to tackle this question the exact same way that we did the previous one on the other page. But although it looks longer, again, it's not even that complicated, really. The only complication comes from factoring at the beginning. So if I look at my first term up here, 2m cubed minus 4m squared, I notice I have a 2m squared that applies to both terms. So if I get rid of that, if I pull out 2m squared out of my brackets, I'll be left with m minus 2. On the bottom, I have a 3m that I can pull out of the brackets. And so if I get rid of that, or take it out of the brackets, I'll be left with 3m, m minus 3. And on the top, since there's no coefficient in front of my first variable, I can solve this one by inspection. So I have my m's there, And if I want negative 6 and negative 1, and then I'm going to use negative 3 and positive 2. And on the bottom, I have a difference of squares here, so that's going to be m minus 2, m plus 2, because I have m squared minus 4. Now comes the fun part of dividing out some of my common factors. So m minus 2 and m minus 2, m plus 2 and m plus 2. I have m minus 3, m minus 3, and then I have m, and I have two m's up here, so I can get rid of one of those. And so my final answer I'll be left with is these two terms of 2m over 3. And then I have to say my restrictions, which are going to be m cannot equal, if I look at the numbers on the bottom, I have both plus and minus 2, 0 coming from this 3m, and I have a positive 3 there. And that would be my final answer. Now, again, remember the first thing we need to do is begin by factoring. Now, if I look at both of these questions here, there might be some multiple steps in the factoring both of these ones, right? And so, since there's going to be multiple steps, I'm going to do part of the factoring on this side of my page rather than right here. But let's start with factoring this top one, since we can just factor that by inspection. Okay, so if I have a squared plus 8 plus 15, if I factor that by inspection, I have a plus 3 times a plus 5. Leave a dotted line and factor over here. Let's begin by doing the top. So over here, a minus 4a cubed. If I factor that, I can bring out an a, and so I'll be left with 1 minus 4a squared. Or, now that I have a difference of squares here, that's going to be a times 1 minus 2a times 1 plus 2a. And I'll write this over here now. A times 1 minus 2a times 1 plus 2a. Now let's deal with the denominators in both cases. So let's start with 6a squared plus 21a plus 9. I can get rid of the 3 right away out of all three of these terms. So that's going to be 3 times 2a squared plus 7a plus 3. Now from here, I can factor by decomposition. So I need to have two terms that are going to multiply, give me 6, and they're going to have a sum of 7. Alright, so I guess 6 and 1 is going to work in that case. And so I have 3 2a squared plus a plus 6 plus 3, because I chose my integers of 6 and 1. Okay, so now if I have this term and these 6a, sorry, and these two terms, I can factor those out, and that would give me 3 times, if I bring an a out of this, a times 2a plus 1, and if I bring a 3 out of these two, 3 times 2a plus 1. Perfect. And that would leave me with 3 times 2a plus 1, and then a plus 3. And so that goes over here. 3, 2a plus 1, a plus 3. And then my last term, I'm going to have to factor using decomposition as well. So 2a squared plus 9a minus 5. Multiply to give me negative 10 and add to give me 9. So if I use 10 and 1, 10 and negative 1, then that'll do the trick. So if I have 2a squared minus a plus 10a minus 5, once I factor that out, I'll be left with a, if I take the a out of there, 2a minus 1, and I can factor the 5 out of here, which should leave me with plus 5 2a minus 1. And so my factors here are going to be 2a minus 1, a plus 5. 2a minus 1 and a plus 5. Okay, so now we can cancel out the factors that that are common to both in both cases. All right, and so I can get rid of these factors here. And so remember, if I get rid of if I switch this one around, first of all, I'm going to be left with a negative outside, right? So this, I'll have to bring out a -1 in order to factor this and turn this around and make it 2a minus 1. Because right now it's negative 2a plus 1. But if I bring out that -1, then it'll make this a negative. But it'll cancel out this on the top and bottom. Okay? And so I'll cancel out these two terms since they're similar. I have an a plus 3 here and an a plus 3. And I have an a plus 5 and an a plus 5. So what I'm left with ultimately is this term, negative a and 3. And so I'll have negative a over 3, and my restrictions are a can't equal -5, -3, or plus or minus 1/2.